Start. Come, it's coming. Okay. Fine. A very good day, students. Today, I am Sanjay Verma from Sanjay Verma School, Kalimpong. I am going to discuss today the chapter Electrolysis, and I will be giving you the basic principles of this chapter. First, I would like to begin with what is electrolysis. Now, let us see. Electrolysis. It is the decomposition of an electrovalent ionic compound in the molten or aqueous solution state. Into ions by the passage of direct electric current through it. So, I repeat once more. What is electrolysis? It is the decomposition of an electrovalent ionic compound in the molten or aqueous solution state into ions by the passage of direct electric current through it. Now, after this, what are examples? Let me give you some examples about what are electrolytes now. What are electrolytes? Electrolytes are basically ionic electrovalent compounds which allow the passage of current through them. Okay. Now, let us learn quickly about strong electrolytes, strong, weak, and non-electrolytes. Now, number 1, strong. Number 2, weak. And number 3 is non-electrolytes. Now, strong electrolytes are those electrolytes which allow a large passage of current through them and they dissociate almost completely. Weak electrolytes are those electrolytes or those chemical substances which allow a very small passage of current to pass through them. Whereas non-electrolytes are those substances which do not allow any current to pass through them. Now, the particles present in strong electrolytes are ions only. Strong electrolytes contains ions only ions. Weak electrolytes contains ions and molecules. Whereas non-electrolytes contains molecules only. So this must be very clear to all of you today. Next I would like to discuss about what is an electrolytic cell. What is an electrolytic cell? This I am going to explain you by drawing a small diagram. Look at this diagram now, all of you. There is a container like this. In this container, I take a solution of an ionic compound. Let me take aqueous copper sulfate solution. Now this aqueous copper sulfate solution which is taken in this container, it is called the electrolyte. This is called the electrolyte. Now, for electrolysis to happen in this container, we need metal plates, 2 metal plates to be immersed in this electrolyte, and these metal plates are connected by means of wires. There is a switch, this is a key over here, and there is a battery there is a battery like this. Now, if you look at the battery, this is the positive terminal, this is the negative terminal. The positive terminal is connected to the switch and then to one of the plates. This plate which is connected to the switch and to the positive terminal, it carries a positive charge. And it is this plate, it is called anode. It is called anode. And the other plate, the other side, the plate which is connected to the negative terminal of the battery, it carries a negative charge and it is called the cathode. It is called the cathode. Okay. Now when the switch is put on, definitely current will start moving in this direction. Electrons will start moving in this direction. But before that, I would like to explain you some more things. It is very important to understand what are the ions provided by this aqueous copper sulfate solution in this. So let us see. When I say aqueous, I mean water. So water molecules, they are going to provide us with H plus and OH minus ions. The salt copper sulfate, which is an ionic compound, it provides us copper ions Cu plus 2 and sulfate ions SO4 minus 2. So in this electrolytic solution, the ions present are hydrogen ion, hydroxyl ion, copper ion and sulfate ion. Now let us see. I am going to write these ions one each in this container over here. So ions are H plus, the other one is OH minus, then we have Cu plus 2 and then we have SO4 minus 2. Now when the switch is on, we know current starts moving in this direction and this plate, which is called the anode, develops a positive charge. And when the electrons come out from the negative terminal of the battery, they accumulate over here on this cathode. And this plate develops a negative charge. Now the ions, they come to know they must move in which direction. The positive ions, that is hydrogen and copper ions, they move to the cathode. They move to the cathode. They move to the cathode. And the negative ions, hydroxyl and sulfate ions, they move to the anode. Now, this is called separation. This is electrolysis. This is called electrolysis. Am I clear? Now it is very, very important to understand that over here, the positive ions between hydrogen and copper ion in the electrochemical series. Now I will discuss electrochemical series after some time. First let me explain how and why are the ions moving in such a direction. The positive ions are moving to the cathode because cathode is negative, and the negative ions are moving to the anode because anode is positive. So oppositely charged ions go to the respective electrodes. Between hydrogen and copper, I'll come to the electrochemical series, then I'll explain you which one is placed lower. Let me tell you beforehand only, between hydrogen and copper, it is copper which is placed lower in the electrochemical series. That is why at the cathode, this copper ion is going to go to the cathode, and here it is going to gain 2 electrons. There is gain of electrons. Can you see? There is gain of electrons. So after gaining 2 electrons, this copper ion is going to form a copper atom. So there is gain of electrons. Gain of electrons means reduction. It means reduction. And on the other side, at the anode side, the hydroxyl and the sulfate come to the anode side. Now between hydroxyl and sulfate ions, the ions which is placed lower is hydroxyl ions. So these hydroxyl ions are going to get discharged because the position of hydroxyl ion is lower in the electrochemical series. Therefore, 4 hydroxyl ions, they will lose 4 electrons and they will form 2 water molecules and 1 oxygen gas molecule. So here we can see at the anode there is loss of 4 electrons. Loss of electron means oxidation. It means oxidation. So here, my dear students, it is very important to understand that at the anode oxidation happens and at the cathode reduction happens. So there is a shortcut method to remember what is happening at the cathode and what is happening at the anode. At the cathode, remember this way. Red cat. red cat. Cathode reduction. At the anode there is oxidation. So we can write anox. Anode oxidation. Pause.